In this video, we are going to finish up the remainder of Unit 1 and take a look at density calculations and some other conversion calculations. So density is a physical property that relates to mass and volume of an object. So we're going to look at the learning objective to find density and use these quantities and mass volume calculations. We're not really going to look at specific gravity. So let's take a look at these two calculations. What volume of isopropyl rubbing alcohol would you use if you needed 25.0 grams? We are given the density of isopropyl alcohol, which is 0.7855. So we're going to use the density as a conversion factor. So we're given 25 grams and we're being asked the volume. And we have the density as 0.7855 grams per milliliter. So we have our 25 grams is given, we have our density is given, and we need the volume. So we first have to rearrange the density equation to solve for volume. So if we multiply both sides by volume, this is what we get, dV equals m. And now we divide both sides by the density and we get volume is equal to mass over density. Now all we have to do is plug in our values, 25.0 grams divided by 0.7855 grams per milliliter. And our grams are going to cancel out and milliliters are going to come up in the numerator, and we're going to make sure that we have 3 significant figures in our value so that, and the reason why is because we started off with 3 significant figures in our given amount. Okay, let's do the next problem. During surgery, a patient receives 3.0 pints of blood. How many kilograms of blood, if the density is 1.06 grams per milliliter, were needed for the transfusion? So this problem, there are a couple of steps that we have to take to solve for kilograms. Let's look at what we're given. So we're given 3.0 pints, and we need to know how many kilograms, and we're also given the density. So we're given 3.0 pints, we're also given the density, and we need kilograms. So when doing these problems, remember you're going to rearrange. We're going to rearrange for the mass. So mass is going to be density times volume. And we need to know how many milliliters we have in 3 pints, because notice that our density is in grams per milliliter. So we've got to first convert that 3.0 pints into milliliters. So we look up a conversion for pints, and we get that there are 473 milliliters per pint. And we end up with 1,400 milliliters. Why do we have 2 significant figures? Because our starting amount had 2 significant figures. So now let's solve for mass. So we're going to have our density, which is 1.06 grams per milliliter, multiplied by our volume. Now, remember, our question is asking for kilograms. So we've got one more step to do. We've got to convert from grams to kilograms. Notice that our grams are going to cancel out, our milliliters cancel out, and we're left with kilograms. Remember, we need two significant figures because the original amount that we started with was 2 sig figs. If at this step back over here where we were going from milliliters to pints or from pints to milliliters, we could have kept an extra significant figure just so that we had a more precise answer. But generally, when our numbers are large, 2 sig figs in a number, it's not going to make that much of a difference if we keep that extra significant figure. All right, so given that mercury has a density of 13.6 grams per milliliter, how many milliliters of mercury have a mass of 475 grams? Take a moment and solve this problem on your own. Pause the video, and then we'll come back with the answer. Okay, so what answer did you come up with? You should have gotten D. Now let's take a look at how to solve this problem. So we're given 475 grams, and we want to know how many milliliters, and our conversion factor is the density, which is 13.6 grams per milliliter. So we're going to use our density, and we're going to solve for volume. Remember, you multiply both sides times volume and then divide both sides by density. Our mass is 475 grams. And we have our density is 13.6 grams per milliliter. The volume is going to be mass over density. So we have 475 grams divided by 13.6 grams per mil. Our grams cancel out and milliliters come up in the numerator. And we end up with 34.9 milliliters. Why are we using 3 significant figures? Because our given amount was 3 significant figures. Okay? Our density is also given in 3 significant figures. So density values that are given can be considered with sig figs, but I generally won't. So if a density is given with a specific number of sig figs, you can use that in your sig fig determination. Oh, let me solve the, okay, there we go. All right, so we've already kind of been using, we've already been doing dimensional analysis by using different conversion factors to calculate our problems. But let's take a look at some more problems. So the factor label method or dimensional analysis is typically when you use conversion factors to solve problems and you cancel out like units. So before we actually do some calculations, let's take a look at conversion factors. So if you check the table in the PowerPoint, you can see that 1 pound is equal to 454 grams. And because this is equal to 1, we can write it in either direction with either the pounds on top or the pounds on the bottom. What now are conversions between deciliters and milliliters? Well, first you have to know what the prefixes mean. 1 deciliter is 0.1 liters, and 1 milliliter is 0.01 liters. You can do the method that I taught you earlier today, where you hop between units. So let's say this is 10 to the -1, and this is 10 to the -3. So there are 10 to the 2 difference between the two. So that means there would be 10 to the 2 milliliters is 1 deciliter, and 10 to the minus 2 deciliters equals 1 milliliter. But if we were going to do dimensional analysis, we can start off with our 0.1 liters and multiply that by 1 milliliter per 0.001 liters, and we get 100 milliliters, which is also equal to 10 to the 2 milliliters. All right. So what are the conversion factors? 1 deciliter is 100 milliliters, or 100 milliliters is 1 deciliter. Why can we do this? Oops, sorry. Why can we do this? It's because these values, it's equal to 1, right? They're an equality, or so equalities can be written in either direction. Okay, so let's do a little bit of practice. So how do we figure out how to solve these problems? Well, first you have to identify the given information, which I have been modeling for you before. The given information is that the length is 21.5 inches. The next step is to identify the answer in the units. What do we need? We need to know the length in centimeters. The last step is to identify conversion factors. So there's none given in the problem, but you have to look one up. This is one that you should memorize. It's pretty simple, that there are 2.54 centimeters per inch. So how do we set up our problem? You always start with what you're given. You were given 21.5 inches is what you were given. Then multiply by your conversion factor. Notice that we want to get centimeters, so centimeters are going to be on top. Our inches cancel out, and we get 54.6 centimeters. Why do we have 3 sig figs? Because our given amount started out with 3 sig figs. All right, so let's do a couple more problems. Here, our first problem is going to use one conversion factor. So if Greg weighs 144 pounds, what is his body mass in kilograms? So what are we given? We're given 144 pounds. We need our mass in kilograms. So we have our given is 144 pounds. That looks like a 16, but it's a B. And our conversion factor is that there are 2.20 pounds per kilogram. 2.20 is actually an exact amount for kilograms. So all we have to do is set up our problem, looking for what we need, and we always start with what's given. 144 pounds was given, and we're going to situate our conversion factors so that we cancel out what we don't need. So we want kilograms, so we put kilograms on top, and we cancel out pounds. So notice that we cancel out from one unit to another. One has to be in the numerator because essentially this is all written over 1, right? So this pounds is in the numerator, this pounds is in the denominator, and so we can cancel them out. So let's see, so the pounds in the numerator, the pounds in the denominator, they all cancel out. In your calculator, you'll get 65.45 kilograms, but because we started off with 3 significant figures, our answer has to be 3 sig figs, and we've got to round this 4 up to a 5 because the number next to it is 5 or greater. Okay, let's try the next problem. Synthroid is used as a replacement or supplement therapy for diminished thyroid function. A doctor a doctor's order prescribes a dosage of 0.150 milligrams of Synthroid. If the tablets in a stock contain 75 micrograms, how many tablets are required to prescribe the medication? So first, we've got to figure out what we're given. What's given is in yellow, 0.150 milligrams. What we need is in green. So we need the number of tablets, and our conversion factor is 75 micrograms per tablet. Now, notice that we need milligrams. Well, we're given milligrams, and we have micrograms in our conversion. So we can't cancel out micrograms and milligrams, so we have to convert our milligrams to micrograms because we want to be able to cancel out both of these units. So we need the number of tablets. So we always start with what we're given. Remember, the 75 micrograms is a conversion because it's per tablet. So anything that's a per is going to be a conversion. So anything that's written in a fraction is going to be a conversion. So we start with what we're given, which is 0.150 milligrams. And we have one tablet is 75 micrograms, but we've got to cancel things out. We cannot cancel out milligrams and micrograms. So we have to add a conversion factor of 10 to the 3 micrograms per milligram. So if you remember that the definition of micro is 10 to the 6, oh, sorry, 10 to the minus 6. Milli is 10 to the minus 3. And if we're going from a smaller unit to a larger unit, we're going to have a positive exponent. So from micro to milli is 10 to the minus 5, 10 to the minus 4, 10 to the minus 3. That's 10 to the 3. So we did 3 hops, and that's going to be 10 to the 3, micrograms per 1 milligram. So our milligrams cancel, our micrograms cancel, and we need 2 tablets. Why am I not putting the 0 here? Because we're talking about tablets, and we can't count a half a tablet if we're counting out tablets, right? We may have to, and generally you don't prescribe half tablets. So you got to give whole 2 tabs. So you don't necessarily need the 0.0 there. Let's do another conversion calculation. A patient is receiving 16 milligrams of methimazole, a drug used to treat hyperthyroid conditions, meaning overactive thyroid. The drug is dissolved in a solution containing 8.0 milligrams of this drug per 1 milliliter of solution. What volume of solution should be administered? All right, let's think about what we're given. What are we given? 16 milligrams. What do we need? The volume of solution. What is our conversion factor? 8 milligrams per mil. So we're given 16 milligrams, and we have our conversion factor is 8.0 milligrams per milliliter, and we need milliliters of solution. So you're always going to start with what you were given, which was the 16 milligrams, and we're just going to multiply that by our conversion. Notice that milligrams are canceled out. If I put the milligrams on the bottom, I can cancel them out. And so we get 2.0 milliliters. We cancel out those milligrams, and we have to have 2 significant figures, and we have 2.0 milliliters. So there are instruments that can measure milliliters and half of them. So it's important that we keep that decimal place and there, because this is a volume and we can measure things with that small volume. All right, let's do another one. A bottle contains 120 milliliters of cough syrup. If 1 tea 5 milliliters is given 4 times a day, how many days will elapse before we need a refill? So what are we given? 120 milliliters. What do we need? The number of days. What's our conversion factor? 5 mils 4 times a day. So given is 120 milliliters. Our conversion factor is 5 milliliters 4 times a day. So that means that we're using 20 milligrams per day. And we want to calculate the number of days before we need a refill. So we always start with what we're given, 120 milliliters, and we're going to set up our conversion so that we cancel milliliters out and we have these left over. So 1 day per 20 milliliters, and that ends up being 6 days. We can say 6.0 days since we started off with 120 milliliters. So let's make that 6.0 days, and that gives us 2 significant figs. All right, our milliliters cancel out. Okay, on this slide, some listed early. Just ignore this 18 down at the bottom until we get there. All right, let's do some more unit conversion problems. What is the volume of a gold nugget that weighs 2.20 kilograms and we're given the density of 19 grams per cubic centimeter? So you're given 2.20 kilograms. We have to figure out, we've got to cancel out these grams. So we can automatically convert our kilograms to grams by simply moving the decimal place 1, 2, 3. So 200 grams. And we're also getting that our density is 19 grams per cubic centimeter. We need the volume in cubic centimeters. So you always start with what you're given, but this is a density problem, so we actually have to reach the density equation to solve for volume. Once again, you're going to multiply each side by the volume and then divide each side by the density, and we get volume is equal to mass over density. Now all we have to do is plug and chug, and we get 2,200 grams divided by 19 grams per cubic centimeter, 150 centimeters. Our given value is 2.20, so we keep our, that's right. Being that 2 years in sig figs, so in 20 centimeters cubed. All right, so one more density problem. How many liters of fat would have to be removed to result in 4 pounds of weight loss, given that the density of human fat is 0.94 grams per milliliter? So we're given 4.0 pounds, and we need to convert this to kilograms and then grams, or we can convert this to grams. For this problem, I use the kilogram conversion. So 2.20 pounds per kilogram, 1,000 grams per 1 kilogram. So we end up with 18 grams. Don't round off here. We're gonna wait until the end to round off. So our is gonna be as accurate as possible. So we are looking for the volume in liters. So we're going to rearrange our density equation to give us volume. We get mass over density is equal to 1818 grams over 0.94 grams per milliliter. Our grams cancel out. We get, I'm missing, I don't know why I have this space right here. Let me make sure this calculation is correct before we move on. Where's my calculator? I lost it. I lost the calculator on my phone, guys. It has disappeared. Hold on. I don't even know where my calculator is. I'm assuming that I did this right. This space is not necessary. So 194 milliliters divided by 1,000 is going. Let me see something. Oh, okay, so there's something missing. There was something missing. So it should be 1934 milliliters divided by 1,000. And so because our density and our given amount is 4 significant figures, we need to round this off to 2 sig figs. So this would have been 1.934 liters. So we're going to round this off to 2 significant figures. All right, last problem that you can work on your own. So pause the video, try and solve this problem on your own, and then come back and let's see if your answer is correct. Okay, what'd you get? The answer is B. We're given 500 milligrams, and we need the number of liters. And our conversion factor is that there are 250 milligrams per 5 milliliters. So we always start with what we're given, 500 milligrams times our conversion factor, 5 mils divided by 250 milligrams. Our milligrams killed, and we end up with 10 milliliters. We are still correct because we only have one significant figure in our given amount. All right, guys, hopefully this was helpful for you, and see you later.